This video goes over some more examples of curve sketching as well as introduces another characteristic, which is holes, which happens when you have the same factor on the top and the bottom. We'll see an example of that in part B. So we're going to start the same way that we did before. The first thing that we're going to find is the x-intercept and the y-intercept. So for the x-intercepts, I'm going to set y equal to 0. And when I have rational functions, that means I'm only looking at the numerator. So this means that x is going to be 0, and my point is 0, 0. For the y-intercept, I'm going to set x equal to 0, and that means that I'm going to evaluate my function when x is equal to 0. In this case, which is also going to give me 0. So my x and y-intercept are at the same point here. Then I'm going to figure out my vertical asymptote. So these are the zeros of the denominator. So that means that I'm going to set my vertical asymptote, or my denominator, equal to 0 and solve, which gives me the equation of my vertical asymptote. And then I can check my end behavior around that asymptote. So as x approaches -2 from the left, what is my function doing? And as x approaches -2 from the right, what is my function doing? We use a test value for this. So we're going to set x equal to -2.1 and evaluate. You should get a negative number, which means that our function is going to approach -infinity. As x approaches -2 from the right, we're going to test a value here. So -1.9. This is going to give you a positive value when you plug it into your calculator, which means that your function is approaching positive infinity as you approach -2 from the right. Our next step is to identify the ordered pairs of any holes. So we are looking for common factors between the numerator and denominator. There are not, so that means that we have no holes here. So if I don't, now I'm going to decide if I have a slant asymptote or horizontal asymptote. I notice that my degree on top is 2. My degree on the bottom is 1. If the top is bigger than the bottom, now I have a slant asymptote. In order to find the slant asymptote, I am going to take my top value and divide by the bottom. I'm going to use synthetic division for this one. So I've got 1 for x squared, 0 for x, and 0 for my constant, because I do need those placeholders. I'm going to bring down the 1. I get -2. I'm going to add those, +4, and then I add those together at the end. So that means that my slant asymptote, the equation of that is x -2. And I also know that I can rewrite my function as x -2 plus 4 over x plus 2. So then if I'm going to do my end behaviors, we'll do them underneath. I want to know as x gets really, really large, my function is approaching my asymptote, and I want to know if it's from above or below. In order to get that value, I'm going to test a large value. So let's say x equals 100. And what I'm doing is I'm plugging it in to that extra piece to see if the value is negative or positive. Here I have a positive value, so that means that I'm approaching that asymptote from above. And then I'm going to repeat the process as x approaches -infinity by substituting in -100. So I'm going to test x equals -100, 4 over -100 plus 2. This is negative, so that means I'm approaching from below. The last thing that I need to do is I'm going to put all of that information onto the graph. So I'm going to start with my intercepts. That happens to both be the same point. Next, I'm going to plot my vertical asymptote, which is over here at x equals -2. And then I'm going to plot my slant asymptote, which is the line x -2. So I'm going to start with my y-intercept. I'm going to go up 1 and over 1, up 1 and over 1, and then I'm going to connect those dots using a dotted line for asymptotes. And I'm going to label it x -2, and then I'm going to fill in the blanks using my end behavior. I know that as I approach positive infinity, so as x is getting really, really large, I'm approaching my slant asymptote from above. So that tells me that this half of the graph is right here. I know that as I approach negative infinity, okay, that is when my graph is approaching my slant asymptote from below. That represents this branch right here. If I go up to my zeros of the denominator, my vertical asymptote, as I approach -2 from the left, I'm going down to negative infinity. So that matches this part right here. Those are the y values that are reflected by those x values. And the very last one is if I approach -2 from the right, I can see that I'm going to positive infinity, which is going to be the second half of my graph in this kind of upper triangular quadrant. Okay, so this part right here matches this part right here, and that is my graph of the rational function with all the key features included. The second example that we're going to do, we start exactly the same way. First thing that I'm going to do is find the x-intercept. So I'm going to set y equal to 0. So I know that that is going to be 0 equals 3x squared plus 10x minus 8. I need to factor the numerator in order to be able to solve that equation. I can factor this into 3x minus 2 and x plus 4. So this is going to tell me that I kind of have two x-intercepts here. So I've got 2 over 3, and then I've got x equals -4. But I can recognize that this one happens to be the same factor on the bottom. So I can actually rewrite my function as factored form 3x minus 2 times x plus 4 over x plus 4. So I'm going to cancel these out. If they can cancel, this means that I have a whole at x equals -4. So what that tells me is it's not actually an x-intercept, it is actually a whole. In order to find the y-coordinate, I'm going to substitute my x value into my new function. So I'm going to say that my function is this. I'm going to evaluate at -4 to figure out the y-coordinate of the whole, which is 14. So that means that I have a whole at -4 and -14, only because I can cancel out those factors. So then things get a little bit more exciting. Okay. Now I'm going to set my y-intercept. Okay. I'm now using this blue function right here. This is what I'm basing all of my work on. So I now have no vertical asymptote because I no longer have a denominator. My y-intercept is -2. Okay. I don't have a slant asymptote because I no longer have a rational function. And so that means that all that's left for me to do is to graph this function y equals 3x minus 2, with a hole at minus 4 and 14. So when I go to put that on, I know that I'm going to start at my y-intercept. I'm going to use blue for this graph. So I'm starting at minus 2. I'm going to go up 3 and over 1 because that's my slope. It makes sense then that my intercept is going to be 2/3. And then if I work backwards, let's see, minus 1, 2, 3, 4. I'm going to kind of go down to where that minus 4 value would be with my line. I have a hole, so I'm going to draw a hole. And what it means is that my function exists for every x value except at x equals 4. So this is my hole, and it is at minus 4, minus 14, which is our next characteristic and last that we're going to be looking at.